Section 4, we were talking about velocity and acceleration today. So just a little scripture on your virtual day from 1 Peter. But even if you should suffer for what is right, you are blessed. Do not fear what they fear. Do not be frightened. Kind of go with that fear not verse, or whatever you're going through. You can fear not because God's got you. Okay, so we've talked about instantaneous rate of change. We talked about average rate of change. Unless it specifies that we want average rate of change, please do instantaneous rate of change, and that is finding the derivative. So from here, when we're asked, we're given the length of a rectangle, its length and width, and we are checking over t is for time, and we want to see how the dimensions are changing. So if this rectangle enlarged or shrunk with these original length and width, let's find the rate of change with respect to time. So all that's saying is find the derivative. Rate of change, find that derivative. So when we multiply area length times width, we would have that product rule. And so I have it set up for you. I want you to pause the video and actually test out what are, like if you get the answer right. So go ahead and find that derivative. All right, there we go with a little product rule review. Well, today we're looking at motion along a line. So right now, motion along a line is just going to be left, right, up, and down. We'll talk about if there's other motion later. But some vocab you need to know. Displacement is just a change in position. And that position is s of t. Average velocity, remember if it's average, that's when you're finding the total change in position divided by the total change in time. So displacement divided by change in time. Whereas instantaneous velocity is the derivative of the position function, and we call that v of t. So basically velocity is speed with direction. If we have positive velocity, you have positive direction for your movement, and it will indicate whatever that is. It's either right or up. And then if your velocity is negative, we're either moving left or down. Speed is the absolute value of velocity, so it's whatever that change of position is over change of time, but it's always positive. And then acceleration is the change of your velocity. So if you're driving like 25 miles per hour and then you increase to 30 miles per hour, that change in velocity was 5 miles per hour over your time period. So it's the derivative of velocity. So here's just a helpful thing that you can pause and write down and take a look at a little bit more on those. Alright, so we are taking a look at Bugs Bunny. He is following this position function. We want to know his displacement from time of 1 to time of 2. We want to know when he's going to hit the ground, his velocity, and his speed. So I actually want you to try that before I explain it in the video. So see what you can find with my little hints here. And then go ahead and play the video to see the answers. Alright, so once again, displacement is just a change in position. So we wanted to find the change from time of 1 second to time of 2 seconds. So when we find that, we actually drop 32, or he drops 32 feet. And again, we found that just by plugging in 2 for t and 1 for t. Now when he hits the ground, that's when our position is 0. There are a couple ways we could have found this 5 seconds. If you weren't sure, you could have just graphed that parabola given, and you would have seen actually 2 answers. You would have graphed it from the zeros, and they were -4 and 5, but when we talk about time, we don't ever have negative time initially unless it says like 4 seconds ago, but it says he started at 320 feet on the cliff, so we are just going to use this 5 for our answer. So again, you could have graphed it and found the zeros. You could have factored it and found the zeros, or you could use a quadratic formula. But 5 seconds is when our position was at 0. Now his velocity is the derivative of position. So all we did was we took our position function, we derived it, and then at the impact is when you hit the ground, well, we said that was at 5 seconds. So once we find our velocity function, we just plug in 5. And so what we were saying is when Bugs Bunny hit the ground, he dropped at 144 feet per second at that exact moment. Now speed is just the absolute value of our velocity, so he is at a speed of 144 feet per second. Now, acceleration is how our rate is changing. So how is our velocity changing? And so we can either double derive our position function, or we can just take our derivative, our velocity function we had here, and derive it one more time. And so our acceleration is actually just -32 when we derive our velocity function. But what does that actually mean? Let's talk about the units of measure. Acceleration says that the label is the change in velocity over the change in time. So our change in time is seconds, that's easy. But our velocity is actually feet per second when we talk about what the label was. That's why we put feet per second here. And so this is kind of a weird thing, -32 feet per second. Well, what that really is -32 feet per second squared. Because I could have rewritten this as feet per second over second, and then remember, instead of dividing by seconds, we can multiply by its reciprocal, and then that's how we get feet per second squared. So our velocity is changing, that feet per second, every second is changing by -32, or dropping, or decreasing by 32 feet. Okay, so then we get to velocity graphs. So we have to pay really close attention of if it's a position graph or a velocity graph. So this one shows us the velocity, and we're moving along the x-axis. So now whenever we see an ordered pair in this graph specifically, our x is time and our y is velocity. So if we see this point right here, 4, -4, what that is saying, at time of 4 seconds, our velocity is -4 feet per second. So every y value is a velocity. So keep that in mind as we answer questions here. When we talk about this, our positive y values mean that our velocity is greater than 0. Our negative y values means that our velocity is less than 0. Okay, so when it says which way does the particle move first, we're talking at time of 0. This is our first movement from 0 to 1 second. And our velocity here is actually less than 0. We are below the x-axis, and so we actually move left. If you want to explain, it's because our velocity is negative. And on the x-axis, we're saying that to the right is positive velocity, and to the left is negative velocity. All right, so when does the particle stop? Well, the particle stops when our change in position over change of time is 0. So when velocity equals 0, well, velocity equals 0 at these 4 spots. So at time of 0, time of 3, 7, and 10. We do not have an increasing or decreasing velocity. There's no change in position over change of time. If we took any of these ordered pairs, like let's take this for example, remember that's time and velocity. So at time of 3, our velocity, our change in position over change of time is 0. And then when does the particle change directions? Well, that's when it goes from left to right or right to left. Well, if we think about it, we can just say velocity changes signs. It actually happens at time of 7. Because all of this here is left, and then all this here has positive velocity, so it's right. So at time of 7 seconds, our velocity changes directions. Okay, so actually, when is it moving left and right? Well, it moves left when velocity is less than 0 or when velocity is negative. Those are saying the same thing. So what's tricky here is, I drew this before. We have to be careful because we said we were stopped at time of 3 and time of 7. So the way we write this, we are moving left. Remember, this is interval notation. So 0 to 3 is not an ordered pair. This is 0 to 3 seconds. But at 3 seconds, we're not going left. We actually stopped. So we say it's in union with 3 to 7. So we broke up at time of 3 because that was when we stopped. Now we move right when velocity is greater than 0 or velocity is positive. Well, that happens when these y values are positive, so above the x-axis. And so we can say from time of 7 to time of 10, all of those velocities are positive, meaning they're going right. Okay, when is a particle speeding up versus slowing down? So this is kind of tricky. It speeds up when velocity and acceleration have the same sign. So velocity and acceleration are both positive, or if velocity and acceleration are both negative. Here's a little example to help us with that. So think about this, it's actually easy when it's positive. You're going 25 miles per hour at time of 1, then you go 30 miles per hour at time of 2. So velocities are 25 and 30. Because they are both positive, we are moving right. Now acceleration is that change in velocity over change in time. So when we actually find our acceleration, when we get 5 over 2, yes, it's positive, but what's happening is that velocity of 5 says you are going right, because it's positive, right 5 feet every 2 seconds. Well, you are already going right. So if you are going right and you're going further right, you're actually speeding up. Both velocity and acceleration have the same sign. It actually works in the same way the other direction. So I know it's kind of weird to think of negative velocity, but again, all that negative says is we're going left. So if we do the same example, 25 miles per hour and 30 miles per hour, but negative, that means we are going left in both cases. So when we find the acceleration, same thing, we find negative 5 over 2. Well, what that negative means is that our change of velocity over change of time is actually telling us to move 5 feet left every 2 seconds. Well, if you're already going left and you are changing by going left even more, you're actually speeding up. So anytime acceleration and velocity have the same sign, you are speeding up. So what we want, those positive, we can do positive first. The positive velocities are right here. But acceleration also has to be positive, and acceleration is the derivative of velocity. So we basically want to say, where is the slope of velocity positive? And that actually happens here and here. So from time of 7 to time of 9. The acceleration is positive, where the velocity is positive. So the slope is positive of velocity. We do the same where it's negative. So velocity is negative here. But if acceleration is the slope of velocity, and velocity is negative, we want negative slope of velocity. So that happens right here. And that happens right here. Everywhere else is either a flat slope or a positive slope. So we would say it's in union with 0 to 1 second, and it's in union, sorry I'm writing this kind of funky, 3 to 4 seconds. Okay, my video cuts off at 15 minutes. So I'm going to pause and make part 2. So please stay tuned for part 2.